Here we're going to look at topic 86, example 3, multiply rational expressions. Part A, what is the product of 2xy over z and 3x squared over 4yz? So I'm going to rewrite this as a product. So we're going to multiply each of these over yz. Alright, so the steps kind of remain the same, or not kind of. The steps are quite similar to what we did previously. The first step, we're still going to look to factor. Then we're going to state our domain. And then step 3. So we're going to say 3 and 4 will be multiply and reduce or simplify. Actually, let's say simplify. The multiply simplify step, you could simplify first and then multiply, or you can multiply first and then simplify. So that's why I'm going to combine those as one step. So here, if we look to factor, each numerator and each denominator, the 4 total pieces, are all monomials, and we cannot factor a monomial. Okay, we can't factor a single term. So the next thing we're going to do is we will just state the domain. So the domain here, there's no x in the denominator, so I don't have to worry about x. But we're going to say all real numbers, except we do have a z and we do have a y. So that first z cannot be equal to 0, and y also cannot be equal to 0. So those are our exceptions. There's no addition or subtraction. Since it's all multiplication, you really just can't have a 0 in there. All right. From there, there's some things that you can look to do. We already did step 2, so factor we didn't have to do. State the domain, we did. When you're multiplying or simplifying, sometimes it's easier to multiply first and then simplify. Other times it's going to be easier to simplify first. I would recommend looking to simplify first before you start combining pieces. So what you are allowed to do is the same way that we canceled out numerator to denominator. You can cancel out numerator to denominator from, like, say, this numerator and this denominator, or this numerator and this denominator. Okay. So it doesn't have to just be from within the same fraction. So what I notice is that the y values, I have a y in the numerator and a y in the denominator, so those can be canceled. And then the 2 over the 4, those can be reduced. So I can reduce this to 1 over 2. So if I have 2 over 4, that's equal to 1 over 2. Right. And then to multiply fractions, we multiply the numerators and we multiply the denominators. So my numerator is x, or 1x, times 3x squared. That would be 3x cubed, right? So x times x squared. And my denominator, I have 2z and z, so that would be 2z squared. Just check again to see if you can simplify. If you can simplify this step, you probably missed something in the previous step, but there's nothing wrong with simplifying here. All right, you could combine them. A couple other options, just to run through this kind of quickly. We had 2xy times 3x squared over z over 4yz. Without going into too much detail, you could have done this and combined your numerators and then your denominators, and then reduced from here if you wanted to. And the y's would still cancel out. This 6 over 4 would reduce to 3 over 2. So you do wind up with the same answer. You don't necessarily have to do the simplification first. All right? You can multiply first. So it is up to you. Some problems will be preferable one way, others will be the other. All right, let's look at part B, which is a bit more involved. So same first 3 steps. Just check that off. So we need to factor, state the domain, and then step 3, again, we can multiply and simplify. You're going to decide which one is done first. All right, so factoring. My numerator, 5x, there's nothing I can do with that. All right, we said before we cannot factor monomial. My denominator, x plus 3, can't factor that. It's not the difference of squares. There's no GCF. So if it's a binomial, we're looking for GCFs and difference of squares. My numerator in the next expression, x squared plus x minus 6, I'm looking for factors of negative 6 that have a sum of a positive 1. So this here is what I get here. Factors of negative 6, 1 and 6, 2 and 3. One of these has to be negative for each pair, so I get 5 and 1. My factors would be negative 2 and 3. Again, I'm not going to go into too much detail with the factoring. That's from another video, but that would be the factor sum method. My denominator, we actually need to fix this. This should say 2x. So let me fix that. That should not say x squared. That should be 2x. Apologize for that. So we're going to factor this as well. So I want factors of 1 to have a sum of 2. This is as easy as it gets. 1 and 1 would be 2. So my denominator is x plus 1 times x plus 1. This becomes that. Alright, so that that fraction is good. My next numerator, x squared plus x, binomial, so look for a GCF. They have an x in common, so I would factor that out using my GCF method. And then my denominator also has a GCF, so I would factor out the 5, and I would be left with x minus 2. Just go through each piece and make sure that they're fully factored. Sometimes there will be a second step in terms of factoring. This one is fully factored. There's nothing else we have to do. All right, from here, you have a couple options on how you decide to, actually, let's do the domain first. Sorry, getting ahead of ourselves. So the domain is going to be all real numbers. Except x equals, we only have an x in this case. So looking at this x plus 3 term, I know that x cannot be negative 3. So x cannot be negative 3. Looking at the x plus 1, they're the same, so they're going to have the same domain, but let's just say we looked at just this one for now. X cannot be negative 1. It's the same case here, so I don't need to repeat it again. I already have that limitation. And then my final piece, this x minus 2, that tells me that x cannot be equal to 2. So my domain, all real numbers except x equals negative 3, negative 1, and positive 2. Okay, now the next step, you have some choices on how you approach this. You can start canceling out right from here. You can put all the pieces together as one fraction and then cancel out. What I really would not recommend, do not multiply everything out. All right, don't actually start distributing and multiplying like 5x into x minus 2. You're going to create way more work than you want. So what you can do is I'm going to, again, you don't have to do this method, but what I'm going to do is I'm just going to combine this into one fraction. So I took all of my numerators, multiplied them together without actually combining them. And then I do the same thing for my denominators. You do not have to necessarily do this step. You can cancel out the previous step. Sometimes I just like to write it this way. So we're going to look for things that can be eliminated, specific groups. I see that I have an x minus 2 in the numerator and the denominator, so I can get rid of those. I have an x plus 3, so I can get rid of that. The x plus 1 in the numerator can be canceled out with one of the x plus 1s in the denominator. All right, it's a 1-for-1 trade. You cannot cancel out both of them. I also have a 5 in the numerator. I didn't mean to erase it, just wanted to cancel it. So a 5 would cancel out with that 5 in the denominator. So nothing else looks like it can be canceled. In the numerator, I have x and x, so I'm going to multiply those. So my leftover pieces, right, I have this x here and this x here. In the denominator, I have x plus 1. So numerator x times x would be x squared. Denominator would be x plus 1. Make sure that you keep in mind that these x's cannot be reduced because this x is tied to the plus 1. Again, I always recommend putting that in parentheses. That way you remind yourself that the x plus 1 have to be canceled as a group. I can't cancel one of them individually. All right, so that's the simplified form of our original product, and we already stated the domain over here, so we're done with that problem. Really, these problems come down to factoring. If you factor the problems correctly, the reducing, simplifying part becomes pretty easy. You won't have to worry too much about that. Always check at the end to make sure that you canceled everything out. Let's say here we forgot to cancel out the x plus 3's. I would have had something like this. And I would have seen like, oh, all right, I missed it. I could have canceled that out. So it is okay if you miss them, you'll see it towards the end. All right, you can go one at a time if you really wanted to. That's it. Have a go at the try it problems and see how you do.